So hey everybody, back working on the Cadillac today on the LS swap, and today what we're working on is the angle of the drive shaft. You know, we put everything in on new mounts and got it all set in place, but the one thing that's been making me nervous is whether or not we have a reasonable driveline angle so that the prop shaft and the U-joints will be lined up properly. So we're going to make some quick measurements here before we go get the prop shaft cut and see if we're in the ballpark or not. Alright, today we're going to try to get some measurement of drive shaft angle and make sure that our mounts are close to where they need to be. And the one thing we've never had is a measurement off the back. So we're going to measure it. Now ideally we may need to come back and do this where we jack up one wheel momentarily and turn this so that it's perfectly vertical. I'd really like to measure from the bottom of the round portion there where the U-joint sits, but I think the tops of here is machined close enough that at least for the first approximation we should be pretty good. Now at this point, you know, it is rotated so that these are pretty much vertical above each other. So I have a magnetic base angle tool that I got from Harbor Freight, and we're going to start with that one, and then I'm going to get my bubble level version out, and we're going to do it both ways. So first of all, let's see if we can get this up here vertically and go across the yoke vertically. And this is a little bit of an eyeball, but it looks to me like we're vertical.
So that
like
one,
that.
It reads, it's between like 1 and 2.
All right. Now, a minute ago we thought it said 90.
Yeah, it's to the right a little bit.
Okay. What if am I changing it this way?
It's right around 91.
Okay.
Whichever way it goes, it's hovering there.
Okay, so it's got about a 1 degree angle on it.
It's settling out. Give it just a second.
Yep, that's fine.
That right there is real close to right on 90 or 0.
Okay, well, it would be nice to be more precise than let's see if try it again here.
Hard to tell for sure, but it looks like it's between 90 and 91.
All right. So maybe half a degree, and which direction is that?
It's towards the back of the car.
So the pinion angle is up by about a half a degree?
Yeah.
Okay.
It's hard to tell because I'm upside down, but...
Yeah. All right, well, we're taking a second run at it. I put the Harbor Freight one on the side of my bubble level to make sure that it was vertical. And then the bubble level section here, the bubble level piece is across the yoke vertically. And you can't see it easily, but there's a bubble on the side over here. And I've been reading it with a mirror. And so right now we've got it so the bubble is centered up. Set down the camera. You can see there's my mirror. We'll take another read on it. But yeah, the bubble's centered up. And the reading on the dial is straight up 90 degrees.
Yep.
And personally, I think the bubble level's more accurate. It's the most accurate. And so it's so it says 90, which means that as the car is sitting, it has no angle on it at all. It's sitting flat. Or the drive shaft would be sitting flat, right?
Mm-hmm.
Now we got to go check the angle of the car and the angle of the engine and see where we're at. All right, so on the front, we're going to work off, for right now, we're going to work off the balancer and do a vertical measurement off the balancer, and I'll use the Harbor Freight tool to make sure I'm up and down. But right now we've got the bubble centered in here, and the bubble's pretty doggone sensitive. You know, if you make much of a move, it'll move. But now that we got that, let's see what we got for a reading here. It looks like we're at about 4.5 degrees. Just kind of get a better. Yeah, we're about 4.5 degrees back angle. And we can double check it. We may want to double check it up here. There's a couple of ways we can go at that. And we'll see what 4.5 does for us. So we're going to take a second measurement here off the valley plate, which is torqued down already. It's a machined surface underneath, so it ought to be pretty close. And I've got a V-block just to space my tool. And we've got the bubble centered. And if I take a look at that one, the answer is, and it's hard to see on these marks, but it's about 4.5 also. It's about 4.5 degrees. It's hard to do, but it's very close to the same. So the answer is we got about a 4.5 degree up angle on the engine, and a 0 to a 0.5 degree up angle back at the back end. Then one of the things we want to do is compare to where we were before with the old engine. And we were pretty careful to take some measurements off the frame. Get this zeroed back up again. And that is a really, really sensitive bubble. But if we go off the frame, we've got a spot here at the front frame mount, and the answer on this one is about 0 degrees, and that means the frame is sitting flat with no angle on it. When we made these measurements on the old engine, we had the car tilted some, and so we're going to just compare measurements. So here's Dan's little logbook, and we started out, measuring pinion angles and things. And when we did it, we had the front and the back were at different heights. One was on the floor and one was on ramps. But we took measurements off the frame and off the engine and off the balancer so that we had a reference point, and one off of the body mount. And now we've gone back and remeasured them, and because we measured the body mount, we can come back to the body mount and we can do things in a relative term, and we can correct, for the most part, we can correct for the idea that we have the car sitting at a little bit different angle than we had before. So right now, it's up on ramps, and we're sitting with a pinion angle of 0, and the balancer on the engine at 4.5. So the engine's at about 4.5. The frame's at about 0 level, which is, pretty good. So the point when you're doing universal joints is there are two ways to go with joints. The best way is usually what they call parallel, which is that your engine would be at a certain angle, your axle would be at a certain angle, and you have equal angles across the joints. The shafts would be roughly parallel, and each joint, U-joint, would have the same angle. In this case, we don't have that. We have more like intersecting angles. So the axle's at 0, the engine's at 4.5, and as long as you're at about 2 degrees across each one with the axes of the two intersecting here, you'll also be in a good condition. Now, as we said, 4.5 may be a little too much, but this is where we can put shims in, and we can bring this up. We can probably get it to less than 4 and bring these angles closer together. And one other wild card in here when you're dealing with a rear axle like this axle sitting at 0, but when you get on the power and you start going down the road, that one's going to want to come up, and it's going to take angle off of this joint and make them closer together. So as we'll get the prop shaft and get it cut and installed, and we'll just have to verify that from tube to angle, tube to engine, that those line up. I'm frankly now not worried, because I know we can get this one, close or better than the original engine was. We aren't moving the axle, and while the prop shaft is going to get shortened by a few inches, it's not much. And the car ran very well with the angles we had, so if I can get it back to the angles before we took it apart, with an engine at about 4 degrees and the axle where it is, we should be in good shape. So now we've made those measurements and rough measurements off the frame and off the front of the engine, off the axle, and I think we're in the ballpark. The engine's at about 4.5 degrees and the axle's at about 0. So the total's 4.5 degrees. It's just about a half a degree more than the original engine had in it. One of the things, though, is we don't have any shims in this. The original mount, this is the original mount for the transmission, it had shims on it, 2 of them actually, that would take a little bit of angle out of the engine and transmission. And currently those aren't in there. We also had a separate mount piece made when we modified the cross member that's about a 1/4 inch thick that we can put between the mount and the cross member. So we knew we could raise things, but we knew we couldn't drop them any further. So right now, like I said, we're in the ballpark, and I think if we add a couple of shims back in, we'll probably be less than 4 degrees of angle, and we could even bring it in a little bit further. What gives me some comfort is, though, that we're very close to where the original engine was. With a few shims, we'll be back to where the car was when it started, and I think we'll be good to go. And Dan can go take his prop shaft now and get it cut, and when we get the prop shaft installed, then we'll do the fine-tuning on shims and get our U-joint angles set. So thanks for watching. That's all for now.